Good evening to whoever is watching this. Today I will be going through the additional mathematics paper for O levels in 2010, paper 1. If there's any questions about the paper, you can leave them in the comments. But anyway, I'll just get started here. I want to talk a little bit about the paper. For those of us who are sitting for AMATs in 2019 or 2020, honestly, right, 2010 paper was quite a breeze compared to what we see nowadays, I would say anyway. 2010 is really not a difficult paper. Both papers 1 and 2 were relatively easy in my opinion, or maybe that was just because I was doing extra practice papers from other schools and things like that. I am not completely sure of how to feel about the papers, but I will say that I was not surprised at all when I was looking through the papers. So let's just get straight into this. So if you come over here, now you will see the paper. So let's look at question 1 to begin. The function f is defined by f of x, which is equal to x to the 4th power minus x to the 3rd power plus kx minus 4, where k is a constant. Given that x minus 2 is a factor of x, find the value of k. Alright, so let me just write that on my board. Alright. So given that x minus 2 is a factor of this, find the value of k. If x minus 2 is a factor of f of x, that means that by the remainder theorem, f2 is equal to 0, right? So let's do this. f2 is equal to 16 minus 8 plus 2k minus 4, which is equal to 0. We'll just work this out in our head, okay? So this is 8, this is going to be 4. 4 plus 2k is 0, so k equals to negative 2. That was pretty easy, right? And then part B, using the value of k found in part 1, find the remainder when f of x is divided by x plus 2. Alright, so now that we know what the value of k is, we will be able to evaluate f of negative 2 to find that, right? So let's do it. F of negative 2 is equal to 16 plus 8. Oops. And then this is negative 2. K is negative 2. This is also negative 2. So plus 4 minus 4. And this is just equal to 24, isn't it? Right. Is there any problem with this question? I don't think so. For question 1, the answer is k is negative 2. For part 1. Part 2, the answer is 24. I should write this. This is question 1, part 1. And this is part 2. Alright, so yeah, this should be okay. I don't even know why it's in the O levels. Let's go to question 2 now. Show that sine x plus cosine x whole thing squared is 1 plus sine 2x. Alright, that is also pretty straightforward. So we have the LHS, which is equal to sine x plus cosine x, whole thing squared, and then we'll just expand this using the normal algebraic way, right? We will have sine square x plus 2 sine x cosine x plus cosine square x. And then sine square x plus cosine square x is 1, 2 sine x cosine x is the double angle identity sine 2x. So this is just 1 plus sine 2x. And this is the right hand side, right? This is probably the easiest A math trigo proof I've ever seen. It's probably not even should not even be considered a proof in my opinion. Just showing that you know how to use algebra and the identities. Well, that's what the definition of the thing is, trigo proofs, but doesn't matter. Hence, find in terms of pi the value of the integral of sine x plus cosine x, the whole thing squared, running from 0 to pi over 2. So that will be equivalent to the integral of 0 to pi over 2. This is 1 plus sine 2x dx. Somebody pinged me on Discord, so give me a minute after this. Alright, so let's integrate this the normal way. This is just x, and then sine 2x is when you integrate this, you're supposed to have a 2 in the front when you do the derivative, but instead this integral is divided by 2, so this will be x minus cosine 2x all over 2, and then we have the limits 0 pi over 2. Alright, and then let's do this. So pi over 2, cosine pi is -1, so this is x, so this side will be half plus half, and then this is pi over 2 plus half, and then minus 0, then minus this, but this becomes a positive because of the minus here. Cosine 0 is 1, so this is half. Wait. Yeah, this is plus, sorry, half because of the negative, double negative. So this is just equal to pi over 2 plus 1. Alright, I'll go and settle that Discord ping. I'll be right back. I'm back. Let's draw ourselves to questions 3 and 4. Question 3, using a separate diagram for each part, represent on the number line the solution of, okay, we'll do the first part first. 3 times 2 minus x is less than x plus 18. So let me just clear my board. Uh, 3 times of 2 minus x is less than x, is it plus or minus? It's plus, okay? In fact, I don't even know why this is here because this is EMATS, right? So let's just do this. So 6 minus 3x is less than x plus 18, so less than x plus 18. And then you will add both sides 4x, right? No, sorry, 3x. Then you have 4x here, 0 is less than 4x plus 12. And then from this, x is greater than -3. That was easy, right? Yeah. Then part 2. 3 times of x squared minus 5 is greater than x minus 1, so and this is greater than something. I believe this was greater than, x minus 1. Okay, so this is also pretty straightforward. Expand this and then make one side 0, right? So we have 3x squared. Then this is minus 15, but we are going to subtract the x here. And then we have 3 times -5, then the minus 1. So minus 14 is greater than 0. So this one we will factorize. 3x minus 7 x plus 2 is more than 0, right? Let me see, minus 7x, yeah, there's 14, and yeah, that's, yeah, correct. Okay, then that means that x is less than negative 2, or x is more than 7 over 3. Okay, I do believe the question said, I forgot about it, I believe the question said represent the solutions on number lines. So let me do that. I will have the line here, okay? Let's say that this is negative 3. Then I'll have a unshaded dot, right? And then this will just go this way. And then for the bottom part, I will have this. I'll have another line. This will be negative 2. This will be 7 over 3. So then I'll have one line going that way, and then I'll have another line going this way. Alright? Then there's one last bit about that. State the set of values which satisfy both inequalities. So that's quite easy. That's just minus 3 is less than x is less than 2, or x is greater than 7 over 3, isn't it? That is the, this is the set of values for x which satisfy both inequalities. Alright, that is, so far you can see that it's mostly been EMATS kind of stuff, right? This is why I felt that the 2010 standard was definitely not up to what we have nowadays. Question 4. A curve has the equation y equals to sine 2x minus 3 cosine x. Okay, let me just write that. Alright, then find the gradient of the curve when x equals to pi over 6. Okay, so first thing we must do is find the dy dx, right? So dy dx, this is 2 cosine 2x, then negative cosine will become positive sine. So 3 sine x, then we just sub x is equal to pi over 6, right? Alright, then let's see. Cosine pi over 3 is square root. Sorry, no. Cosine pi over 3 is half. So this is just 1. Then sine pi over 6 is also half. So this is 3 half plus 1. This is 5 over 2. Alright? Part 2. Given that x is increasing at a constant rate of 0.06 units per second, find the rate of change of y when x is equal to pi over 6. That's also pretty simple. We know that dx dt is equal to 3 over 50, isn't it? So we find dy dt, right? So dy dt will be dy dx times dx dt, which is just sorry, this one, the x is what again? Yeah, x is still pi over 6, okay? So this is just going to be 5 over 2 times 3 over 50. And this is 3 over 2 times, okay, so this is 1, this is 10, so this is 3 over 20, okay? So 3 over 20 units per second. So, yep, question 4. Oops. Let's have a look at question 5. Question 5, that little symbol on the left side tells you that if you're watching this video after 2020, then if you're taking AMATs in 2021 and onwards, question 5 is not applicable to you. So part 1, sketch the curve of y equals to the modulus of 9 minus x squared for negative 5 is less than or equal to 5 is less than or equal to positive 5. Okay? So let's do it. Okay, so let's just do this in our heads, yeah? What is the turning point? The turning point will be when it's just equal to 0, right? When x is 0, which is just 9. So let's do it like this. Do I have enough space like that? No. Should draw it a bit further down. Okay, here's my origin, my x, my y. Okay, so we know that it's going to cut somewhere here. Let me draw that a bit lower for a reason. Okay, so we know it's going to cut here somewhere. So this will be 9. Okay, and we know that the intercepts are going to be plus minus 3, right? So this will be minus 3, and this will be positive 3. Let us draw the extra thing here. This one will be 5, and this one will be negative 5 because that's our defined range. And then we will draw the graph accordingly. So this one will go up, and this one will go down. Oops. This one will go down here, isn't it? And then this one will shoot up to 5 around. That's not a good curve. I can't see what I'm doing because I don't want to block the board too much. Alright, so that will go somewhere up there. This will go somewhere up here, right? And then we know that this will be 16. Okay? So yeah, we know this is 16 because if you sub 5 here, then you know that this will be 16, okay? So this is your graph of y equals to 9 minus x squared modulus the whole thing. I think this is quite a basic graph, so should not have any issue. Let me get rid of the bottom part because I need space for part 2 later. Find the x-coordinates of the point of intersection of the curve y equals to the modulus of 9 minus x squared and the line y equals to 27. Alright, that's simple. Just equate the two to each other. 9 minus x squared modulus equals to 27, which means that 9 minus x squared is equal to 27, which has no solution. Or 9 minus x squared is equal to negative 27, which has solutions. So we know that x squared is equal to 36, x is equal to plus minus 6. That's the x-coordinates of the intersection. If you sketch this, you'll know that 27 somewhere up here, then you know that there will be negative 6 here, 6 here. So that should be pretty straightforward as well. Question 6, part 1, differentiate x e to the 2x with respect to x. That one is just a simple product rule, isn't it? d dx of x e to the 2x power is equal to x 2e2x e2x 1, and that is just 2x e to the 2x plus e to the 2x, isn't it? I'm not going to factorize this because it's easier to leave it this way for part 2, which is use your answer to part 1 to show that the integral of x e to the 2x running from 0 to 1 is equal to e squared plus 1 all divided by 4. Okay, so we want to find the integral of 0 to 1 x e to the 2x dx. But what we have is this form. So what I'm going to do is I'm going to equate this to a series of integrals. So we're going to start with this one, 2x e to the 2x plus e to the 2x dx, because we know that this is x e to the 2x plus c. Then we will subtract the integral of 0 to 1 e to the 2x dx. Toka, I need you to be a bit careful. And this whole thing here will divide by 2. And this is equal to, let's see. So this is this will just be x e to the 2x, which I don't need to write the plus c because this is definite integral. Minus then integral of this. This one will divide by 2, so we have e to the 2x over 2, going from 0 to 1, all over 2. Let's see. So this is, so when this is 0, then this whole thing is just 0. When this is 1, this is e squared, right? So I have e squared minus this thing. When this is 1, this is just e squared over 2. So minus e squared over 2. Then I know that this is minus is 0. Then I have the plus something. Then when this is 0, this is 1 at the top. So this is just plus half. Alright, and this is, don't forget, this is all over 2. Alright, let's see. So if I equate this, then I'll have half of e squared plus half all over 2. So there will be a quarter somewhere. So how about I divide everything by 2 and then just simplify the top, right? So let's multiply by top and bottom by 2, okay? So this is e squared plus 1 over 4 shown. So you should be able to get from here to here because I just multiply the top and bottom by 2, right? And then get rid of this. There's this 2 here, so just cancel, becomes e squared. Then this is plus 1, right? Should be simple. And that is your 6 part 2. I'll take a bit of a break here and just check that my recording is stable. I will go and make a second recording and then I'll join the 2 videos together afterward. I'll see you guys in a bit. Alright, I'm back. We are not going to do question 7 on stream because it is a linear law question with graph drawing. I will do that. I will give you guys an image in the description for that question. So we're just going to go to question 8. The equation of curve is y equals to x cubed plus 3x squared minus 9x plus k, where k is a constant. So find the set of values for x for which y is a decreasing function. Okay, so we must find dy dx. dy dx will be equal to 3x squared plus 6x minus 9. So for it to be decreasing function, must be less than 0. So x squared, actually I don't need to do that. X squared plus 3x minus 2 is less than 0. Then x2 then minus 3. Okay, then x plus 3, x minus 1 is less than 0. So therefore negative 3 is less than x is less than 1, right? That part is quite simple. Part 2, find the possible values of k for which the x-axis is a tangent to the curve. If the x-axis is a tangent to the curve, that means that y is equal to 0 and dy dx is also equal to 0, which means that x is equal to 1 or x is equal to a negative 3. So let's do this. When x is equal to 1, y is equal to 1 plus 3 minus 9 plus 5, plus k. I already know the answer, so I jumped to it. Okay, equals to 0, so k is equal to 5 in this case. And then when x is equal to negative 3, y is equal to negative 27 plus 27 minus actually it's plus 27 plus k, which is equal to 0. Everything is 27 here. So we know that k is negative 27. Right? So these are the two possible values of k, 5 or negative 27. Depends on x equals to 1 or x equals to negative 3. Okay? For question 9, once again, if you are sitting for syllabus 4049, or you're taking A-Maths in 2021 or later, question 9 is not applicable to you. It will not be examined for your syllabus. Given that the roots of 3x squared minus 2x plus 1 equals to 0 are alpha and beta, find the quadratic equation whose roots are alpha plus 2 beta and 2 alpha plus beta. So I had this written out already because I made a mistake earlier. So let's try this again. Alpha plus beta is equal to negative b over a, 2 over 3. Okay? Then alpha times beta is equal to c over a, 1 over 3. Then sum of roots is just 3 alpha plus 3 beta, right? So that's 3 times of alpha plus beta. So 3 times of alpha plus beta, quite simple. This one is 2. Then what about this times 2? That one's a little bit trickier. Alpha plus 2 beta times 2 alpha plus beta. Let's expand it the normal way. We have 2 alpha squared, then we have alpha beta, and then we have 4 alpha beta. So let's do that. 5 alpha beta plus 2 beta squared, and this is equal to 2 times of, alpha squared plus beta squared, which we know is alpha plus beta squared minus 2 alpha beta plus 5 alpha beta. Okay, so let's do this. Alpha plus beta squared is 4 over 9 minus the 2 alpha beta, which is 2 over 3, right? Yeah. So 4 over 9 minus 2 over 3, that's negative 2 over 9. Negative 4 over 9 plus the 5 alpha beta, that's 15 over 9. So this is 11 over 9. Okay? So therefore, the equation is x squared, then you have the sum of roots as 2, so minus 2x, 11 over 9 plus 11 over 9 is equal to 0. Okay, that should be correct this time. I made a mistake with my algebraic manipulation the first time around and I didn't get the answer that I needed to. So this is your quadratic equation. So question 10 is, the first part says, without using a calculator, show that tangent 75 degrees is equal to 2 plus square root 3, right? Yeah. Okay, so for this, we will use our addition formula, right? This is tangent 30 degrees plus tangent 45 degrees, or over 1 minus tangent 30 degrees, tangent 45 degrees. Hopefully my marker lasts me for the rest of the video. Alright, this is 1 over square root 3, this is 1, or over 1 minus just 1 over square root 3, right? Because this is 1. Okay, so let's do this. So when we multiply by the conjugate, we realize the top actually just becomes squared, and then the bottom will become 2 over 3. So this will be 2 at the bottom, 3 times of 1 over square root 3 plus 1, whole thing squared, and let's expand this. Then I'll have 1/3, so I have 1 plus 2 of these, so 2 over square root 3 over 3, then yeah, 2 square root 3, then over here I'll have just plus 3 all over 2, and this is equal to 2 plus square root 3, right? Yeah, so that's it's not too bad. I just had trouble recording because some friends are not respectful sometimes. Not implying that they don't not always respect me. I don't even know what to say. Alright. I'm gonna show you that actually for another second or two, because I don't have enough space, so I'm gonna need to clear the board for part 2. Alright. So for the second part, we need to do secant square 75 degrees equals to 4 tangent 75 degrees. Okay, so here's what I'm going to do. Alright, so we know that we want to find secant square 75 degrees, right? Alright, we're going to apply one of our identities. This is equal to 1 plus tangent square 75 degrees, right? And this is equal to 1 plus this thing squared. Okay, then this is equal to 5 plus 4 square root 3. Then this thing is 3, right? So sorry, this should be 1 plus 4, 5, then plus 3. 8 plus 4 square root 3. And this, we can see that we can actually factor out 4 here. 4 times of 2 plus square root 3. And based on this, we know that this is 4 tangent 75 degrees. So basically, we need to show the first part to be able to do the second part. Alright? Question 11. I'll clean the board a bit. This should be the last time I have to record. After all this, I will edit the video, do just a little bit of editing, put the bits together, so don't worry too much about it. Alright, question 11. A curve is such that dy dx is equal to 8 over x squared minus 2. So given that the curve passes through the point 1 and 5, find the equation of the curve. Okay. So we will integrate, right? So y will be equal to, so let's integrate. This is 8x to the negative 2 power. So this will become negative 1 at the top, but divide by negative 1. So this will become minus 8 over x minus 2x plus c. And we know that when x is equal to 1, I believe that was what it said, right? So when x equals to 1, y will be equal to minus 8 minus 2 plus c, which is equal to positive 5. So that means that c is equal to 15. So therefore, the equation is y equals to negative 8 over x minus 2x plus 15, right? So that should be, that's quite simple. Part 2, find the coordinates of the stationary points of the curve. I'm pretty sure you can do this yourself. I'm not even going to work this out, yeah? We already know that dy dx must be 0, which means that 8 over x squared must be equal to 2. So x squared has 4, x is equal to plus minus 2. That was quite quick, right? Okay, part 3, find these. I'm not going to show you because it's just find the second derivative and then determine the nature of the stationary points. Okay, So d square y over dx squared should just be equal to, this will be yeah, negative 16, right? Negative 16 over x cubed. Okay, so when x is equal to 2, d square y over dx squared equals to negative 2, which is less than 0. And therefore, this is a maximum point. Right? And when x is equal to negative 2, d square y over dx squared is equal to positive 2, which is greater than 0, which means that this is a minimum point. Simple? Yeah, that's simple. On to the last question for 2010. Okay, question 12, the last question. Write down the equation of the circle with center A, negative 3, 2, and radius 5. Alright, so that is just going to be x plus 3 squared plus y minus 2 squared equals to 25. I think all of us can do the first part, right? Part 2, the circle intersects the y-axis of points P and Q. Find the length of PQ. Intersects the y-axis means x equals to 0. So 3 squared plus y minus 2 squared equals to 25, which means that y minus 2 is equal to square root of 25 minus 9, which is plus minus 4. Okay, so y is equal to 6, or y is equal to negative 2. So therefore, PQ equals to 8 units. That should be easy enough, right? Part 3, state the x-coordinate of B, given that it is positive and the radius of the second circle is, state the y-coordinate of B. I keep reading things wrong. So state the y-coordinate of B, it will be the same as A, it's just 2. Part 4 is, given that the x-coordinate of B is positive and radius of the second circle is square root 80, find the x-coordinate of B. Okay, so let's use the point of 6, okay? So then I'll use my length formula. So let's let B equals to k over 2. Sorry, k and 2. Because we know that B, the y-coordinate is 2, right? So let's apply our length formula. We have 0 minus k squared plus 6 minus 2 squared is equal to 80, which means that so this means that this is 4, right? So this is 16, so this will be 64 over here. So 0 minus k is plus minus square root, okay? So k is equal to plus minus the square root of 8. Plus minus 8. The negative rejected because we are told that it is positive. So this is equal to 8. Alright? Finally, the equation of the circle center B, which passes through P and Q, may be written in the general form. So state the value of G and of F and find the value of C. Okay. So we know that the center of the circle is minus G minus F. So we have 8, 2, which means that for part 5, I'll write it here. G is equal to negative 8, F is equal to negative 2, because the center of the circle is minus G minus F. Then we have g squared plus f squared minus c is equal to 80. Then this is 64, this is 68, so c is equal to negative 12. And yeah, these are all your values. Okay, so that has been 2010 GCE O-level A-Maths paper. Personally, as I said at the beginning, I felt that's not too difficult of a paper, but there were a lot of slip-ups during the recording process. First half went perfectly fine, then a lot of random things went down, and yes, it was not pretty for me. But I will just do a little simple bit of editing to put the things together so that it's more seamless. So don't worry about it too much. Thank you for joining me today. I hope that I can do the future O-level papers. I will try to do all the A-Maths O-level papers running up until the most recent 2019 papers as well before the start of the 2020 O-levels. So that if you are watching this in 2020 or whatever year that you're taking A-Maths, you will have sufficient revision material. Okay, thanks so much for joining today. I'll see you guys real soon.